Hello, my name is Allison, and I will be talking to you about the windmill project that Liam, Jimmy, and I worked on this semester for our additive manufacturing class through CSU. Our project purpose was to create a fully functional desk-sized windmill through the use of additive manufacturing. For our project, we focused on 5 main design goals. Our first goal, and most important to us, was to ensure that the propeller actually turned once it was on the final product. Our second goal was to make sure the windmill was durable. The durability of the parts allowed us to have confidence that we could assemble it and disassemble it many times. It also gave us a higher probability of the parts withstanding the mail system, since we created it in one state and shipped it to Colorado to turn in at school. Our next design goal was to make the windmill desk size. That goal was created partially based off of the requirement to ship the windmill once it was made. The other factor in creating this goal was to allow the windmill to fit on a desk without taking up too much space, since as college students, we know we always have books everywhere and homework. So this would ensure that we could still have a windmill and you could see it, as well as when you graduate, you're going to be moving to a new place, and this would make it easy to move. Our fourth design goal was to have no significant blemishes on the visible surface. This would allow us to create a beautiful final product and make sure that the design looked good. Our final goal was to meet the requirements set forth in class. Some of those requirements included having a shiny surface, an embedded metal thread, and then being creative of our project, and the other ones set forth. Now I will go over the actual design of our windmill. For our project, we broke the windmill up into 6 different parts to be built. The first part was the propeller blade, which can be seen up in the top left-hand corner of the slide. We went with the classic design of a windmill and had 3 blades on our propeller, and you can see that they have a tilt to them like normal propeller blades to catch the wind as they turn. Our next part is the gearbox. The gearbox holds our 2 gears together, as well as our propeller blade, which I will show on the next slide a better view of what that all together component looks like. Our next part is the shaft. The part after that is the base. We decided to make our base 4-prong to have a better stability and to ensure that our windmill wouldn't tip over. Our final 2 pieces are the gears. Here I only show 1 gear. The second gear is almost identical to this design. The only difference is the center of the second gear is a complete hollow circle in the middle. Here is a better view of what our end product looks like. so you can have an idea of how our gear and gearbox and propeller all fit together. Our gearbox, as you noticed in the previous slide, had 2 holes on either end of it. That was to ensure that we could have our screw or all thread fit through. Now this all thread is what holds together the propeller and the gear, so that when you turn the propeller, you turn the gear, which allows you to actually get a working propeller. As you can see on the close-up picture on the left-hand side, we have an embedded thread in our gear. This was created by placing a nut into that hexagon indent from our design, as well as one in the propeller blade. Now I'll go into the form, fit, and function of our project. For form, we went with Windmill. For fit, as I showed in the previous slides, we had our windmill broken up into 6 different parts so that we could assemble and disassemble them in order to ship in the mail. And these parts could fit into each other. We have the shaft fit into the base, and then the gearbox, propeller, and gears all connect to each other through the use of that awl thread, which then sat on top of the shaft. The function for ours, like any windmill, was for the propeller to be able to turn. Now for our design, we decided to go with our shaft to be a hollow tube. This allowed us to cut back on our time to create the shaft, as well as the amount of material we needed to produce the part. For our base, which can be seen on the left here, that you notice our design, we decided to go with curved edges. That was to help with the aerodynamic look that a windmill has, to give it that nice sleek look. For our project, I want to highlight 2 main things. The first one is that all of our parts ended up turning out great, especially our gears, which we were the most worried about since they were going to be the most complicated. Next was that we were able to achieve our first design goal, and that was to have our propeller blade actually turn. And I'll show you in this video what our final project can do. You can see we were very successful in getting our propeller to actually turn on our windmill. One main lesson we learned while doing this project was to make sure you know your machine's capability when you're designing your parts to be made. For us, our original shaft was designed to be 150 millimeters. However, when we went to create the part, we realized that the machine could only create parts up to 140 millimeters. Luckily for us, it was an easy fix. We just went back into CAD and shortened the shaft to 100 millimeters, so the machine was able to create our part. However, if our propeller blades would have been longer, then we would have had to go back in and shorten our propeller blades to make sure that they didn't hit the ground. But like I said, we were lucky and our design was good enough where our propeller blades were fine with us shortening the shaft. Going into this project, we knew that with our windmill design, the gears were going to be our most difficult. So we decided to do several trial runs and have different prototypes to see which would work best. We used Prusa i3 for the prototypes. As you can see, our first three that we ran were not very good, but with each run, it got better and better. For our final parts for the gears, as well as our shaft, the base, the propeller blade, and the gearbox, we used Stratus 450. We had to make a few slight adjustments to the extrusion multiplier, as well as increase the layer height to 0.10 millimeters in order for us to get those final products you can see in the top right hand corner. Our team wanted to give out some final tips for future projects. The first one is to remember that requirements are key. Requirements are very important in your project, and you want to make sure that you have them correct at the beginning, because if you don't get your requirements right at the beginning, then your final project turns out to be something that you didn't want in the end. You also have to remember to keep going back to your requirements throughout every stage of actually building your project, because we found that most people, they'll put down their requirements at the beginning and they won't even look at them until they go to the very end of their project, and then they look at it, their final project and their original requirements, and they realize that their project actually doesn't fit their requirements now. So make sure that throughout the entire project you're looking at your requirements and making sure that your project still fits those requirements, or if you need to go back and change your requirements. The second tip is that communication is very important, especially nowadays. And like with our project, we had all three of our team members were in different areas. So you have to make sure that you have some form of communication that everybody checks almost daily, so that you can stay up to date on how the project is coming along and making sure that you agree with the different changes that happen, or if you need to let them know that something you want switched. So luckily with our technology that we have nowadays, it's a lot easier to stay in communication with each other. Our final tip is to make sure you still have fun. We noticed a lot of people, and we did this several times, where you just focus on the project, but you have to remember that in the end, this is to help build your skill set for additive manufacturing so you can use it in the real world. Thanks for listening to the project. The Windmill team hopes that you learned something. Thanks.